Hello everyone, I am Udaya, working as Assistant Professor in the Department of Agricultural Engineering, Sri Shanmuga College of Engineering and Technology. In today's lecture video, we are going to discuss about the topic evaporation and its measurements. So as we all know, evaporation is the process in which the surface water bodies it's converted from its liquid form to gaseous state. That is, it is stored as water vapor in the atmosphere. So evaporation, once again, evaporation is the process by which water changes its state from liquid form to vapor state. So below the boiling point, generally it is the process which affects the surface water bodies, and due to its continuous process, soil moisture is getting reduced and vegetation is getting affected due to loss of moisture from surface water bodies. Evaporation, it's one of the important phenomenon in our hydrological cycle. So it transfer water from lakes, rivers and oceans, reservoirs, and also from groundwater. So it acts as a major loss of water from surface water bodies. So generally, let us learn some physical process of evaporation. We all know at boiling point, water molecules, when we heat the water at boiling point, we all have seen some molecules and bubbles will rise up. The kinetic energy of water molecules, it makes the water droplets, water molecules to move faster, and when it start moving faster, it starts escaping from the water surface, so that we can visibly see the decrease in water level. That process is called evaporation. Evaporation rate increases when the surrounding air also can accept more moisture. There are certain factors which are affecting evaporation. Let us discuss in brief about these factors. So temperature plays a vital role, and surface area, humidity, wind speed, boiling temperature. These are all the basic factors which are important to increase or reduce the evaporation rate. So as the temperature, as the atmospheric temperature increases, it increases the evaporation rate. So that increase in temperature also increases the kinetic energy of water molecules, so that it starts escaping very fast from the surface area. And relative humidity, so relative humidity, whenever there is a low humidity, it increases the evaporation rate, because the atmospheric temperature and the vapor absorption rate is high. In terms of low humidity, when the humidity is very high, then the evaporation rate is considerably reduced. And also wind velocity plays a major role, because already water is evaporated and it is stored above the water body in the form of water vapor. So when wind flows from one place to another place, so the wind is having the tendency to move the water vapor already formed, so that the water body, the surface above the water body, it becomes emptied. So then again the new evaporation will get increased. So when wind removes the saturated air above the water surface, the evaporation will become more and more, because already formed water vapor, it moves from one place to another place. So again the new vapor state will form. Next one, solar radiation. We all know, as heat energy is increased, clear sky will lead to higher evaporation and atmospheric pressure. In case of low pressure belt, the evaporation rate will be higher, and in case of widened surface area, vast surface area, the water is stored, the more and more it get evaporated. In case water is stored in deep places, deep water bodies, the evaporation is considerably less when compared to widened area. And dissolved salts present in the water, it reduces the evaporation rate considerably. So now let us discuss how can we measure the evaporation. Okay, so evaporation measurements, generally evaporation cannot be measured directly from large water bodies, it can be measured indirectly. So we can use evaporimeters. So evaporimeters are pan which is used to store water, and we can measure the amount of evaporation from it. So let us discuss in detail about pan evaporation method. Okay, so there are four kinds of evaporimeters available. First one is pan evaporation. So in the base point is class A evaporation pan. It is designed by United States. So it is used to measure the evaporation loss from a free water surface. Here a pan of known diameter, that is 121 centimeter. It is kept above the wooden support of 15 centimeter high. As you can see in this image, a wooden plank is kept above the ground level. So in between wooden planks you can see visible gaps, so which increases the air flow and which makes the free flowing, which keeps the temperature up, temperature and maintains the atmospheric characteristics. So here by measuring the amount of evaporated water, we can fill the water in this pan, and in 24 hours duration how much water is getting evaporated, that one we can measure it from here. It is a circular pan which is made up of galvanized iron. It is installed on a wooden platform in order to maintain the air circulation below the ground level, in order to ensure the free movement and maintain the atmospheric temperature. So as you can see this image, this is how a pan evaporimeter will look like. So water is filled in it and it is covered with a net or mesh. So in order to get rid of birds and insects drinking water from the pan, so that we will be able to exactly measure the amount of water evaporated. So here we can measure the amount of evaporation using this formula: E is equal to Kp into Ep. So Kp is the pan coefficient. So it's the values ranges from 0.6 to 0.8. So using the amount of water evaporated from this known amount of known volume, we can measure the lake evaporation by using the coefficient. So the next advanced version of evaporimeter is ISI standard pan. This is Indian standard pan. This is a slightly modified version of pan, class A pan. It is developed by ISI, Indian Standard Institutions. It's widely used in India. It's a square shaped evaporimeter. The class A pan is a circular one. Its dimension is 0.9 meter by 0.9 meter. Depth of the pan, it is 25 centimeter. It is either made of galvanized iron or copper. It is mounted on brick masonry platform, above which wooden plank is again provided in order to ensure the free flowing of air. So the main advantage of this pan evaporimeter is that it is having some advanced accessories like hook gauge. It is fixed in it in order to measure the water level, and still well it is installed in it in order to avoid the wave effects formed in the evaporimeter, and rain gauge also installed nearby in order to measure the rainfall, so which is absent in class A pan. These are the additional accessories which is installed in our Indian standard pan. So the main working principle is that a pan is filled with water up to a fixed level. Here the daily drop in water level is measured and corrections made for rainfall and additional water added. So the main advantage of ISI standard pan is the design is simple and economical, and it is suitable for almost all the Indian climatic conditions. And heat exchange drawback is that heat exchange can happen from sides and bottom. And evaporation, it is observed that evaporation rate is higher than the natural water bodies in the container. The next type of evaporimeter is Colorado sunken pan evaporimeter. So it is Colorado sunken pan. It is installed on the ground level. It is installed below the ground level, not well below. It is installed up to the ground level. It's installed in the ground. Okay. So it is developed developed in order to reduce the errors due to heat exchange, as the water body like ponds, lakes are present on the ground, directly connected to the ground. In order to replicate the same principle of pond or lake, this is developed. This is a square pan of dimension 1 meter by 1 meter and depth is 0.5 meter. The material, it's made up of galvanized iron, and it is installed with rim flush with ground surface. The additional accessories are that hook guards, still well, rain gauges are provided, and wire net is provided in order to prevent birds or insects drinking water from it. Pan is filled with water and evaporation measured by drop in water level. So how much reduction in water level, we can measure the amount of evaporation. Since the pan is sunken, here the heat exchange is considerably reduced, and it is a minor replica of the lake or pond. It's higher than class A pan, and its typical value of Kp, coefficient of evaporation, it ranges from 0.75 to 0.85. So advantage, it's closely resembles the natural water bodies, and it reduces considerably the wind and heat effects. The main drawback is that its installation cost is high, and sometimes drainage problems may occur during heavy rain. The next type, last one, is US Geological Survey floating pan evaporimeter. So this evaporimeter pan is installed in the lake or reservoir. As you can see in this image, it is made to freely float in directly on a lake or reservoir. It's a circular plan. Its diameter is 1.2 meter and depth is 25 centimeter. It is made up of galvanized iron. It is made to float in between the lake or reservoir in order to replicate the exact scenario of the exact temperature, climatic conditions, physical factors. It faces the similar conditions of the water body, so that it is anchored in order to avoid drifting or wind movements and all. It is anchored. So here the pan is filled with water, as you can see in this image. Here the water level is measured daily using a hook gauge. So drop in water level gives the evaporation rate, and here the rainfall correction need to be applied. So the advantage is that it closely represents the natural evaporation, and here the less heat error is observed and more accurate when compared to other land pans. And its limitations, it's costly and difficult to maintain, and it can be, there are the possibilities of getting affected by waves. So these are the four types of methods of measuring evaporation by means of evaporimeter. Okay, so this, I hope this class lecture video would be useful for you to understand about evaporation and its measurement. Thank you for watching.